Hello friends, it's me Umesh Mallik and welcome to the video. Our today's chapter name is rest and motion, that is kinematics. And let's start with the very first topic, that is rest and motion. How we can define the terms rest and motion? In very simple understanding or in very simple words, we can say if a body is changing its position or just moving as the time passes, then the body is said to be in motion in that time interval. And if the body is not changing its position or not moving as the time passes, then the body is said to be in the state of rest in that time interval. But defining these terms in this way is not the correct way, because we have already studied that the terms rest and motion is dependent to the observer, because for one observer the body may be moving or not moving. That's why the rest and motion terms is dependent to the observer. Let us take one example. Suppose or here is a whiteboard. As I can see, this whiteboard, as the time passes, this whiteboard is not moving. That's why this whiteboard is in the state of rest with respect to me. But as the astronomer in the moon sees, then the earth itself is moving. That's why all the things on the earth's surface, that is including this whiteboard, is also moving. That's why this whiteboard is moving with respect to that astronomer. And also next example is, there is one bus moving on the road, and inside that bus there are two passengers, passenger A and passenger B. Suppose passenger A is not moving and remaining still. That's why the passenger A is not moving with respect to the passenger B. That's why for passenger B, the passenger A appear to be in the state of rest. And if the same passenger is observed from next observer outside, in the outside environment near the road, then the passenger A will appear in the state of motion. That's why before defining the terms rest and motion, we have to specify the observer, and then and only then we can define the terms rest and motion. That is, rest and motion is totally dependent to the observer. These rest and motion are the relative terms. Now here we have to define the next term, that is the observer or the reference frame. What is the reference frame? To locate any object, we have to identify the reference frame. Suppose the very simple way for reference frame is, we can draw x, y and z axis. X, y and z axis. Suppose this is the reference frame, and now we can locate. Suppose the body is at the point A. Here we can give the coordinates for this point A, the body in the point A. And now if we adjust or fix one clock here in this reference frame, and if we observe the body at the point A, and if the body A changes its position, or if any coordinate x, y and z, if any coordinate changes as the time passes, then the body is said to be in motion. And if any coordinate here is not changing as the time passes, then the body is said to be in the state of rest. That's why we come to the conclusion to the definition of the rest and motion is, if a body changes its position as time passes with respect to observer, that is the reference frame, then the body is said to be in the state of motion with respect to that observer. And if a body does not changes its position as time passes with respect to the observer or reference frame, then the body is said to be in the state of rest with respect to the observer. Our next topic here is distance and displacement. To understand about the distance and displacement, let us represent one reference frame represented by the x, y and z axis, and let there be a body initially at point A in the time t is equals to at the time t is equals to 0 second, the body is at point A. The body A starts to move. It reaches to point C and finally reaches to point B at time t is equals to t second. Here the length of path traveled by the body, that is the length of path ACB, is called the distance traveled by the body. And if we simply join these 2 points with the straight line, then this straight line gives the displacement of the body from initial position to final position. That means the total length of path traveled by a body is called the distance traveled by the body. And if we join the initial and final points with the straight line, then the length of that straight line joining these 2 points is the displacement of the body. Here displacement is the vector quantity. Its magnitude is given by the length of this AB segment and its direction is from initial to final point. And the distance is the scalar quantity because it has only the magnitude but it do not have the direction. The magnitude of the distance is given by the length of this ACB segment. That's why let's take one example. This displacement only depends on the initial and final point only. And now let's take one example. Suppose a body is moving in a semicircular track of radius 40 meter. Here is given the semicircular track and its initial point is A and final point is B, and the radius, if we suppose this to be O to be the origin of the semicircular track, then the radius from O to B, the radius is 40 meter. And if the body starts from point A and reach to point B, find the distance traveled by the body and find the displacement of the body. Solution: here distance will be given by the arc from A to B, and that will be pi r. That's why this will give 40 pi meter. Therefore distance is 40 pi meter. Also displacement is equals to the distance. Displacement is given by the length of AB, or displacement is given by the line which joins the initial and final points. The initial and final point is joined by this diameter. The length of the diameter will be the displacement. Therefore diameter here is AB, which gives 2r is equals to 2 into 40 meter is equals to 80 meter. Therefore the displacement here is 80 meter and the direction of this displacement is from A to B. Here our next topic is average speed and instantaneous speed. Speed is a scalar quantity. Okay, now let's understand this average speed and instantaneous speed. The average speed of a body in a time interval is defined as the total distance traveled by the body divided by the time interval. If the body travels a distance s in the time t1 to t2, then the average speed is defined as v avg, this is the average speed, is equal to total distance s divided by total time interval t2 minus t1. This equation, this average speed, gives the overall rapidity of a body. The rapidity or slowness of the body may vary from instant to instant. Sometimes the body may be rapid and sometimes the body may be slow, but this average value gives the fixed or constant value of the speed. That means this average value gives the overall rapidity of the body in this time interval t2 t from t1 to t2. That means average value gives the average speed gives the overall rapidity of the body in the time interval. Now let's move to the instantaneous speed. The speed of a body at any fixed or particular time or instant is called instantaneous speed. At any instant, the speed of the body is known as the instantaneous speed. That means speed of the body at particular instant is called instantaneous speed. For understanding instantaneous speed, let del s be the distance traveled in the time interval t to t plus del t. That means in the time interval del t, the body covers the distance del s. The average speed in this time interval is given by total distance del s divided by total time interval del t. As del t approaches to 0, if del t approaches to 0, here I have drawn one graph, distance versus time, and let this curve is the function of distance and time. Here at time t the body is at A, and at time t plus del t the body is at B. That means in del t time interval the body covers del s displacement. Here as del t approaches to 0, the del s also approaches to 0, but the ratio del s over del t has a finite limit, and this finite limit is known as the instantaneous speed. That means the instantaneous speed at time t is defined as, it is denoted as by b. B is equals to del t tends to limit 0, del s divided by del t. It is simply the derivative of distance with respect to time. That means instantaneous speed is given by the derivative of distance with respect to time. V is equal to ds divided by dt. The average speed is defined for a time interval. The average speed is defined for time interval, but the instantaneous speed is defined for a particular instant. Here instantaneous speed is also called speed, or speed simply is known as instantaneous speed. Now let us take one example to understand about average speed and instant. Here the problem is the distance traveled by a body in time t is given by s is equals to 2t square. That means this distance is the function of time. Find average speed of the particle during the time interval 0 to 5 seconds, and b the distance the instantaneous speed at t is equals to 5 seconds. Solution. Here distance is the function of time. That's why s is equals to 2t square. If we put here t is equals to 5 seconds, then it will give the distance traveled by the body in the time interval from 0 to 5 seconds, because at t is equals to 0, the distance is 0. That's why if we simply put t is equals to 5 seconds, then t is equals to 5 seconds in this equation, then it will give as total distance traveled by the object in the time interval 5 seconds. That's why s is equals to 2 into 5 square is equals to 2 into 25 is equals to 50. This one is in meter, that's why 50 meter. Now average speed in the time interval this 0 to 5 seconds is given by total distance in the time interval 0 to 5 seconds divided by total time interval. Here total distance is 50 meter and the total time interval is 5 seconds. Therefore the answer will be 10 meter per second. That's why the average speed of the body is 10 meter per second. Again in B number, the instantaneous speed at 5 seconds. Also, we know the instantaneous speed is given by the derivative of given by the derivative of distance with respect to time. That's why here ds by dt is equals to d by dt 2t square. Here this is the instantaneous speed. Therefore, instantaneous speed is equals to, we'll get 2 into 2t. Therefore, b is equals to 4t. Now, at t is equals to 5 seconds, the instantaneous speed will be b is equals to 4 into t is equals to 5 is equals to 20 meter per second. That's why instantaneous speed at t is equals to 5 seconds is 20 meter per second. In this way, we can calculate the average speed or the instantaneous speed of the body. Now let's move to the next concept. If the speed of the particle at time t is b, the distance traveled by the body in the very small time interval del t is given as ds is equals to b dt. That means the small distance traveled by the body in small time interval dt will be given by ds is equals to b dt. The total distance traveled by the particle in a finite time interval t1 to t2 can be obtained by summing over this small distance ds as time changes from t1 to t2. That's why s total distance will be given by the integration of v dt from t1 to t2. And if we have the curve speed versus time, if we have the curve, then in the time interval from t1 to t2, if we want to calculate or obtain the distance travel in the time interval t1 to t2, then we can find the total distance by simply obtaining the total area under the curve from the time interval t1 to t2. This area will give the total distance traveled by the body in the time interval t1 to t2. Let us just take one example. Let there be a graph v versus t. This is the graph. The speed linearly increases as the time increases. That's why here we are asked, if we are asked to find the distance traveled by the object from the time interval 0 to 3. Here at t is equals to 0, the speed of the body is 0 meter per second, and at time t is equals to 3 seconds, here the time is in second, the speed of the body is this 6 meter per second. Here speed is in meter per second unit. Now, if we are asked to find the total distance traveled by the object in this time interval 0 to 3, then we can find the total distance by simply obtaining the area of this triangle. Therefore, the total distance can be given by the area of the triangle. The area will be given by half into base into height. Here half into base is 3 unit and the height is 6 unit. It will give 2 3 is 6 is equals to 3 into 3 9 meter. Therefore, the total distance here traveled by the body is 9 meter. In this way, by integrating, we can obtain the total distance traveled by the body. Now let's come to the topic average velocity and instantaneous velocity. Velocity itself is a vector quantity because it has both magnitude and direction. That's why average velocity and instantaneous velocity are vector quantities. Now, the average velocity of a particle in a time interval t1 to t2 is given as its displacement divided by the time interval. That means displacement divided by the time interval is known as average velocity. Suppose in the reference frame x, y and z, at time t is equals to, or at t is equals to t1 second, at t1 instant the body is at point A, and at t is equals to t2 second the body is at point B. Here the total displacement can be obtained by joining the straight line between these 2 points A and B. That's why the AB line gives the total displacement of the body in the time interval t2 minus t1. That's why the average velocity can be obtained by a displacement vector divided by total time interval. Displacement vector here is AB vector, the direction is from A to B, AB vector divided by t2 minus t1. Here average velocity is total displacement vector divided by total time interval. Also here in the figure, if we apply the vector rule, then we can find AB vector to be OB vector minus OA vector. Here OB vector is simply the position vector of point B. Let this position vector of point B, that is OB vector, be denoted by R2 vector. Therefore we have replaced OB vector by R2 vector, and here OA is simply a position vector of point A. Here OA vector is represented by R1, therefore OA, here OA is replaced by R1 vector. That's why AB vector is final position vector minus initial position vector. That is, displacement is final position vector minus initial position vector. Hence the average velocity is obtained as R2 vector minus R1 vector divided by T2 minus T1. That is total displacement divided by time interval. Here the average velocity only dependent to the initial and final positions. Whatever may be the distance or whatever may be the path traveled by the body, it doesn't matter, but only the things which matter is the initial and final points. Whatever the path the body can travel reaching from A to B. That's why only what we want is the displacement vector for defining the average velocity. That means only initial and final points are required. Therefore finally we get average velocity is R2 vector minus R1 vector divided by T2 minus T1. Now let's take one example. A body traveled in a semicircular arc ABR. Here let us suppose A and B, there be a point, semicircular arc. This is a semicircular arc. This is point A and point B. Let we join A to A and B. Here is the origin. AB arc from t is equals to 0 second at A, that means at t is equals to 0 second the body is at point A, to t is equals to 30 second at point B. That means in the time interval t is equals to 30 second the body is at point B. If the radius of the track is 60 meter, here the radius is 60 meter, find the average velocity. Here the body has traveled this semicircular path to reach point B, but we do not need that. It is not necessary which path is followed by the body to travel from A to B. We only need the displacement from A to B, and the displacement will be given by the line AB, which is the diameter. The total displacement is equals to AB is equals to 2R is equals to 2 into 60 meter is equals to 120 meter. We have got the total displacement. Again the total time is here 30 seconds. Now the average velocity is total displacement divided by total time interval, and we get 120 meter divided by 30 seconds is equals to 4 meter per second. This is the magnitude of the average velocity, and the direction here is from A to B. That's why we have calculated the average velocity. In this way we can calculate the average velocity. Now let's talk about average instantaneous velocity. Let's talk about instantaneous velocity. let the average velocity of the body in a short time interval del t be average vector is denoted like this. If del r vector be the displacement in this time interval, then average velocity is equals to displacement vector, small displacement vector divided by del t. Now, if del t approaches to 0, then del r also approaches to 0, but the ratio del r vector divided by del t has certain limit or certain value, and that value is known as the instantaneous velocity of the body. That means the instantaneous velocity v vector of a body can be given as v vector is equals to del t tends to limit 0, and the ratio of del r vector divided by del t is equals to dr vector divided by dt. This equation gives the instantaneous velocity of the body. For very small time interval, del r is along the line of the motion. That means the body moves in the direction of the motion is same. That means del r is the direction of the displacement is same to the direction of the motion. So the length del r equals the distance del s traveled in that interval. That means displacement will be same as to the distance. That's why, so the magnitude of the velocity, we find the magnitude of the velocity, then magnitude of dr vector divided by dt is equals to magnitude of dr vector divided by dt, or magnitude of dr is ds, that's why ds divided by dt. But v is equals to ds by dt, it gives the instantaneous speed of the body, which is the instantaneous speed of the body at time t. That's why the magnitude of the velocity is also called as the speed or the instantaneous speed of the body. The instantaneous velocity is also called the velocity. Now, let us talk about the average acceleration and instantaneous acceleration. Suppose the velocity of a body at time t1 is equal to v1 vector, and the velocity at time t2 is v2 vector. The average velocity can be given as average velocity is equal to change in the velocity, that means v2 vector minus v1 vector divided by total time interval t2 minus t1. Here, for calculating the average acceleration, we do not require the velocities from instant to instant. What we require is only the initial velocity and final velocity to calculate the average acceleration in that time interval. That means in this way we can average acceleration is defined. Now let us talk about the instantaneous acceleration. Suppose in a very small time interval del t, there is the small change in the velocity, that is del v vector. By we can obtain the ratio of del v vector divided by del t, which is defined as the average velocity. And if del t approaches to 0, then del v also approaches to 0, but the ratio of del v vector and del t vector gives the certain limit, and that is known as the instantaneous acceleration of the body. Or we can simply say instantaneous acceleration of the body can be defined as a vector is equals to del t tends to limit 0, ratio of del v vector and del t is equals to dv vector divided by dt. That means acceleration is just a derivative of velocity with respect to time. And instantaneous acceleration is also known as acceleration.